Hello. So let's look at these last two examples from the 8.3 note sheets. So here we have this region that's bounded by the graph of y equals square root of x. So y equals square root of x is this guy. And then y equals e to the negative 3x. So again, an exponential, but it has a negative in the exponent, so it's flipped to be decay. So that would be y equals e to the negative 3x. And then the vertical line at x equals 1, as shown in the figure. So the region is the base of a solid. For this solid, the cross section is perpendicular to the x-axis. So again, if we have an x-axis, that's going to be dx. And the cross section is a rectangle. And that is going to be my a of x, or the area that we're going to use. And then specifically for that rectangle, the height is 5 times the length of the base in the region. And now we're going to find the volume. So perpendicular to the x-axis means that my rectangles, or the boxes, are going to be lined up in that direction. And those lines represent the base. So obviously a couple of things we want to think about is we need to figure out our a of x. Then you want to think about the bounds. So obviously I have an intersection here. I need to figure that guy out. And then I'll do the integral. Okay, so first thing is find a of x. So if you want to pause and try to do that first, I would do that now. Okay, and then I'm going to go through it. So welcome back, and I'll go through it. So you are doing a rectangle. The height is 5 times the length of its base. So the base is going to be the top minus bottom. So base, or the b, is going to be the top minus the bottom. And again, I can use that in this case because the square root of x, for any x value I pick, the square root of x is above the e to the negative 3x. So I can just do that right away. Okay, so top minus bottom in this case is square root of x minus e to the negative 3x. And again, get in the habit of putting parentheses around that. The length, so that's the length. I'll just put an L there instead of a base. Okay, now the height is 5 times the length. Now that's super easy to write out. Height is equals, so height is 5 times the length. So, and we know this is the length, so we get square root of x minus e to the negative 3x. So here's my length, here's my height. So obviously for an area of a rectangle, you just multiply those two pieces together. And now we can write this in a little bit easier way because this guy matches this guy. I can just do a squared, but I have square root of x minus, and then e to the negative 3x. Okay, so there's my a of x. And then the second piece is we need to figure out our bounds. So they give you the upper bound here of x equals 1, but we do need to figure out that other intersection. And we're going to do that like we did in the last video. I want you to try to do that with zeros again. So again, just a reminder, these two functions, when you set them equal to each other, so this is to find the bounds. But when you set those equations equal to each other, that is where you find the intersections. And in order to just find the zeros, instead of doing the intersections, you can subtract and set that equal to 0. And then what that does is it kind of coincides with what we did up here, right? The top minus bottom piece, which does make the integration in the calculator just slightly easier. Okay, So again, if you want to try and find the bound, the A value by yourself and store it, try that on your own right now. Okay, and then we'll come back. I'll go through it. So basically, you're going to plug this into y equals. So I did that already here. I'm going to graph it. So there's my graph. And then I'm going to find that 0, which should be coincide with the intersection, the x value anyway. Okay, so I'm going to be going to the left, enter, going to the right, enter, and then enter one more time. So here is the x value for the intersection. So I'm going to make sure on my main screen that is what's in, oops, just hit X, sorry, enter. So that is what's in there. I'm going to write that down. So I'm going to let A equal, and that was 0.238734. Okay, back at the calculator, I'm going to store that value. So you just hit store, and I'm going to put that in A. And I'm just sort of randomly picking A. It doesn't matter what letter you do. Just got to remember which one you want. So that confirms that A is now the value I wanted. Okay, so I had to edit for a second. Sorry. Let me just erase this. I realized I screwed that up. So we are going to do the integral from A to 1. And then you're going to plug in your A of x when you do this on the calculator. Now, since we already defined it here, I'm just going to write the A of x. But in the calculator, so remember what is in here. It is the subtraction, the top minus bottom piece, and that is this inside function. So in the calculator, let me go to the main screen. I'm going to pick the integral, and I'm going to go from A to 1. And then my function, or my A of x, was 5 times, and then the top minus bottom is y1, so you could just do y1 in there, and then squared. Okay, and that's with respect to x. That looks good. We hit enter, and then we have the 1.554. Let me just flip over to my page. Yep, that looks like what it is. So 1.554 would be the volume. So the volume would be, and you write that there as well, 1.554. Okay, so that's a different type of cross-section. So that's a rectangle, and then given those particular constraints. All right, so the last one is using the y's again. So here, find the volumes. Again, we're finding a volume bounded by this curve in y equals 0, which we'll draw in a second, and whose cross sections are perpendicular to the y-axis. So we're going to do a dy this time, and they are semicircles. So remember, with the semicircles, 1/2 pi r squared, but we will want to think about it in terms of diameter, because the diameter, again, the diameter is going to be the top minus the bottom, or in this case, because we're doing dy, is the right minus the left. Okay, so first thing I'm going to do is just sketch it since I don't have a sketch. And it's going to be y equals 4 minus x squared. Okay, so let's graph that. We have 4, and then minus x squared would go like that. It's also bound by y equals 0. So remember, this is y equals 0. But this time we're doing dy. So you want to think about these semicircles being perpendicular to the y-axis. So they're going to be going across in that direction. Okay, if we were to try and draw this three-dimensionally, because I think it might be helpful. So we have, we start at 4, we do our parabola down this way, and again, we're looking at putting the semicircles this direction. So if you try to draw the actual semicircles, you go like this, and then they would sort of slowly get smaller and smaller and smaller as you go back towards that 4. So you get sort of this, I don't know, tent-looking thing that, that tapers down to the 4. So that's the volume that you are looking for. Okay, so using those semicircles and doing a dy. So the first thing you want to do is figure out, and this time it's going to be a of y. Okay, so pause and try that on your own. Okay, so welcome back. First thing we got to do is figure out this, get the x's by themselves and do it in terms of y. So I would get, I'm going to move the x squared over and then move the y over. So I get x squared equals 4 minus y. Square root that. You do need to do plus or minus. So you're going to have a positive square root of 4 minus y, and you're going to have a negative square root of 4 minus y. Obviously, the negative square root is on the, on the left. So this one's the positive, and then this one would be the negative. Okay, so my a of y would be equal to, well, let's figure out the diameter first. So the diameter is going to be that right minus left. So the right is the square root of 4 minus y minus, and then parentheses, the left is negative square root of 4 minus y. And remember, that is the diameter, but we can put it together, minus the negative, so there's 2 of these, and there's the diameter. Okay, so if I put that into this semicircle equation, I'm going to be doing 1/2 pi, and then the radius is going to be 2 square root of 4 minus y over 2 squared. Okay, then obviously this stuff will cancel, and then this square root squared will also simplify. So I get 1/2 pi, and then this would just become 4 minus y. Okay, the second piece is to figure out your bounds. Because we're doing y values, that's pretty easy to do because we're going from y equals 0, and then as we graphed it, we know this is going to be y equals 4. So my bounds are just going to be from 0 to 4, and those are y values. And then obviously my third step is to do the volume piece. So the volume is equal to, so a of x is this guy. We're going from 0 to 4. So 1/2 pi times 4 minus y with respect to y. On this one, I'd like you to try to do this by hand without a calculator. So pause and try to do that on your own. Okay, welcome back. So you can take out the 1/2 pi, and then we're going to integrate with respect to y. So there's the integration, and we're going to evaluate from 0 to 4. So I'm going to plug in my 4. So 4 times 4 is 16. 16 divided by 2 is 8, minus, and then when I plug in 0 minus 0, that's going to be 0. So this is, that piece of it's just going to be 0 times 1/2 pi, so that's just 0. That doesn't matter. So now I have 8 divided by 2, which is going to be 4 pi. So there's an example doing dy with semicircles. See you soon.